Okay, question number C, continued from there. So earlier what did we do? We put the clay block over here, we fired a bullet over here. As a result of it, it started moving like this and stopped here. Okay, now what we do is, we are not putting it here. So the experiment is repeated with the clay block placed at the edge of the table. We kept it at the edge of the table and we fired the bullet over here. Okay, the initial speed of the clay block is 4.3 meter per second. So here it is going at 4.3 meter per second, right? So as a result of it, horizontally, the table surface is 0.85 meters above the ground. 0.85 height of it is also given. Ignoring air resistance, calculate the horizontal distance traveled by the clay block before it strikes the ground. So what is he asking? He's asking you what is the horizontal distance from here to here, what is the horizontal distance? Let us say this is r. You know how to calculate the horizontal distance in case of a projectile motion. What kind of projectile is this? This is a horizontal projectile motion, which you should write r is equal to ux into t. What is ux? The x velocity. X velocity is already got, which is nothing but your 4.3 multiplied by t. But the value of t is not known. You need to find the value of it r. You should get the value of t. How do I get the value of t? You already have this height, right? So we can use the y equation here. It should be minus h should be equal to uy into t minus uy into t minus half ay into t square. I am applying equation of motion for the vertical y axis. In that case, what is minus h? Minus 0.85 minus 0.85 is equal to uy. What is uy? We did not drop it downwards, right? So it was 0 minus half into what's ay? G, right? Into t square. Okay. So thus the final expression that I get here is nothing but t square. This negative and this negative goes away. So t square should be equal to 0.85 multiplied by 2. This 2 goes upwards, divided by g. Okay. Let us calculate what is this value. How do I get it? Where is my calculator? Right. So this should be 0.85 star 2 divided by 9.8. So when I do this, I get the answer 0.1734. 0.1734. In other words, if I take the square root of this, let me take the square root. Square root of this one gives me 0.416. 0.416 seconds are nearly equal to 0.42 seconds over here, right? 0.42 seconds is the answer that I get over here. Next, what do I do? I should not stop here. Now I need to find the value of r here. The value of r here will now be equal to ux into t, which is nothing but 4.3 into 0.42. Let us do this value. What is that value now? Once again, I am going to take 4.3 star 0.42, right? When I do this, I get this as 1.8 meters. 1.8 meters, which is the correct answer. Thus, we have got the value of the distance the block falls from the edge of the table. So, this value is seen to be 1.8 meters. Okay. So, it's for 4 mark. Now, how do I divide this 4 mark into? The first one is this equation. Okay, 1 mark here. The second one is arriving at a value until here. This will definitely take you 2 marks over here, doing all these values. And finally getting the final answer, right? So, stepwise it should be shown. Okay, next let us move on to the next one. The diagram in C shows the path of the clay block neglecting air resistance. The previous one, neglecting air resistance. On the diagram, draw the approximate path of the shape of the path that the clay block will take, assuming that the air resistance acts on the clay block. Okay, so very easy, but it is asked for 3 marks, right? So what all steps should you actually take into consideration? That's what we need to look into. Now is asking you, with the air resistance, what will happen? With the air resistance, the object will fall here only. Okay, there are 2 things that you need to look into. The first one is the line that you draw here should be before this range. First thing. Second one is, see, as it falls down here, when the velocity, when it is approaching, when the velocity becomes lesser, higher and higher, that means your y velocity becomes higher and higher, it almost falls by a vertical line. Okay, see here what happens is Vx is here, Vy is slowly increasing. See, I will draw the diagram. This here only Vx we had. Here we had Vx, Vy was so much. Here we had Vx, Vy was this much. Vx, Vy was this much. So every year Vx was same. But when it went away here, see, Vx started increasing. So here Vx like this. See, this arrow increased like this over here. Here what happens is already there is an air resistance. So naturally this arrow that you have written here will become smaller and smaller. Will become smaller and smaller. This is really smaller over here. But this is larger, right? This is becoming larger and larger. So you should get a vertical line like this. The first one is the distance should be smaller. Okay. First one is distance is small. Small. Second point is that the curve should be almost vertical. Almost vertical. Okay, so these two should be there, and finally label this, and then you say this is with air resistance. With air resistance. Okay, so this third one is labeling. Okay, so let us see. So finally we have covered all the 13 marks together. So this is for 3 marks over here, right? Okay, let us move on to the next one.